Hi, I'm Vince Kurtz.
I'm Peter Wise.
And I'm Isaiah Breckville.
And we are the Quad Fathers, designers of the project AutoQuad. It's an autonomous quadcopter that uses these rangefinders here. They are right there, black circle. They are ultrasonic in that they emit a very high frequency sound wave. And basically like a bat, they would send a chirp out and then they listen for that chirp in return. And they measure the time that it takes for that chirp, the echo, to come back. And we then can calculate a distance based on how long it takes to receive the chirp. And using that distance, we can give the AutoQuad, the quadcopter, signals to change its position or direction based on how far away it is from an obstacle.
So kind of some of the motivation behind this, or what are the applications of this? Well, one thing we thought about is in flying in areas of low visibility, such as fog or smoke, or like in a building or something. This could potentially be used for search and rescue type things where you can't actually see, using like traditional video cameras, but this doesn't actually need to see anything to navigate because it's using only sound. And the other nice thing about having an autonomous quadcopter is that it makes it a lot easier to learn to fly. So instead of having to constantly control the throttle and try to make sure you don't go too high and don't crash into the ground, just flip the autonomous switch, suddenly boom, you're just hovering and you can just play around in that plane instead of having to deal with the elevation.
As you can see from these LEDs, we're getting data from the 5 rangefinders. These 4 correspond to 4 rangefinders in each of the directions. So if you watch this one, it'll go on when my hand is close and my hand leaves the range, it turns back off. The blue LED is controlled by the bottom looking rangefinder, and it turns on when we're in a desirable range right there, and if we're too low, it turns off, and if we're too high, it turns off. And these are ways of showing us that we're getting good readings as we're in flight. We have 2 modes: manual mode, which flies like a normal helicopter, and autonomous mode, where we use 5 PID loops to keep the quadcopter stable, keep it from hitting barriers on the left, the right, the front, and the back. When it encounters a barrier and the red light is on, it will drift away from the barrier until the red light is off. Now we're going to demonstrate the AutoQuad in action. This is entirely manual mode, so I'm controlling everything with this transmitter.
The blue LED is now on. So Vince is in the desirable range, but not yet in autonomous mode.
Now this is in autonomous mode.
You'll notice that being an obstacle gives the rangefinders a signal to tell the quadcopter to direct its motion.
If we fly over a different height, such as this box, it will adjust its altitude to stay at a desirable distance above the ground. I also have manual control with the transmitter to override any signals that it might be getting from the rangefinder. This helps if we get into any trouble, then I can always pick it out. Watch out for the top. normally we can put it back into manual mode to land it.